Calculus BC, our station activity problem number 10. Once again, just like this last video on problem number 9, you can see we don't have an obvious antiderivative present. I do see a composition, however. This is really indicative of being able to do a u substitution. So I'm going to let u equal 1 minus 2x because that is what's in the interior here. Du would be negative 2 dx. And we could solve and say dx is du over negative 2. So my integral will be the square root, I'm going to call that yellow portion u. My dx is going to be du all over a negative 2. But here we go again. I'd like to change my boundaries. This down here is x equals 0, and if x is equal to 0, looking at this substitution, plug in a 0 for x, you're going to get u is equal to 1. Likewise, if you were to have x is equal to negative 4 up on top here, well, 1 minus 2 times negative 4, well, negative 2 times negative 4 is an 8, 8 plus 1 is a 9. So you'll have a 9 up there. So I'm going to factor out a negative 1/2, and I'm going to look at this as u to the 1/2. And now I just have to do the fundamental theorem. The fundamental theorem says bump this power up by 1, and that will be adding 2 over 2, you get 3/2. But then I'm going to divide by 3/2, which is the same thing as multiplying, by 2/3. You can see the 2's are going to cancel out. You're going to be left with a negative 1/3. And then I'm going to plug my numbers in. I'll have 9 to the 3/2 minus 1 to the 3/2. And 9 to the 3/2, guys, I hope you remember very well. It's the square root of 9. That's that 2 right here. And then we're going to cube it. Square root of 9 is 3. 3 cubed is 27. And 1 to a power here is just going to be a 1. 27 minus 1 is 26. So we'd have a negative 1 times 26. That's negative 26 all over 3.